So in the previous lecture, we have solved some problems based on the lines of regression. So we have seen how the lines of regression can be calculated. Okay. Now we have to go further. Okay. So using lines of regression, how and what more we are able to do. Okay. So let us try some more examples with some more ideas. Okay. Okay. So now we have to see some more examples based on the line of regression. Okay, so we have solved some examples already. So let us see the another example. Okay, but before that, we'll try to understand some remarks. Okay. So we know the line of regression, and we know the line of regression of x on y, and we know the line of regression of y on x. Okay, so we know the relation between the coefficients. Okay, so we have dxy is equal to r sigma x upon sigma y. Okay, so that's what we have, sigma x upon sigma y. Okay, and we know dyx, okay, is equal to r into sigma y upon sigma x. Okay, now if we multiply this to byx and bxy, then we have, okay, so we get, okay, what will get is r square is equal to, see, multiply this two. Okay, so we'll be having r square is equal to bxy into byx, and hence I am able to write r is equal to square root of bxy into byx. Okay, so this is one relation we are able to get. Okay, moreover, what we know is, see, what we can have is, suppose this r square, so any square is always positive. Okay, that's what we know. So any square is always positive. That means this both the terms will have the same sign. Okay, so what will be having? The signs of dxy and byx are always same. Okay, so that is what you know is, if bxy is negative, then byx is also negative, and if bxy is positive, then byx is also positive. Okay, so this bxy and byx will have the same sign. Then only this r square will be positive. Okay, so if r square is positive, what is the value of r? So r will have the positive and negative. Okay, but you can see r is a square root, so it may be positive, it may be negative. But this equations or this equation restricts the sign of r. So r will have the same sign as byx, because sigma y and sigma x, these are the standard deviations and are always positive. So this term is always positive. So sign of r depends on this term. Okay, or sign of r depends on this term. And we know this byx and bxy, as per the remark 2, they follow the same sign, and hence r also follows the same sign. So third, what we can say is, the signs of r Bxy and Byx are always same. Okay, so that is if Bxy and we know for Byx, okay, either this or this. Okay, so we can have or Byx is negative, then R is also negative. Okay, and if Bxy or Byx is positive, then R is also positive. Okay, so that's what we can have. Then using this relations, okay, so either you can have this relation, okay, or you can have this relation. So using these relations, we are able to calculate R, we are able to calculate Bxy and Byx, or we are able to calculate any of these standard deviations. Okay, if one is known. Okay, and now we have to see this kind of problems here. Okay, so what we have here, we'll see. So now you can see this question. In this question, we have to find the value of R also. Okay, and moreover, we have to find the equation lines of regression. Okay, so when it is said lines of regression, that means you have to find both the lines. Okay, so let us find the solution of this. Okay, so before going to the solution, one thing I want to ask you: have you understood the remarks? So, are you clear with the remarks? Because that we are going to use later. Yeah. Okay, that's great. Okay. So these remarks will be, sir. Yeah. What is Dipesh is asking? Dipesh, it was your question that how R will be negative. Yes. Okay. So basically, when we started with the correlation coefficient, okay, what is the correlation coefficient? Okay. So correlation coefficient means whether there is a possibility between the two data, that is there any relation? Okay. So that was our initial question. Is there any relation in the given two data sets? Okay, and if there is any relation, what is that relation? Okay, so then up to what extent we can claim that there is a relation? That is the meaning of R, small r. Okay, so there are two possibilities. Either there will be a relation or there will be no relation. Okay, so if there is a relation, then up to what extent? So if the value of R is positive, then there might be a relation. Okay, and the value of R we convert into percentage. It will give you the strength of the relation, that at what strength we can say that there is a relation. Okay, and suppose there is no relation. Okay, so there might be a relation, there might be no relation. So if there is no relation, okay, then R value will be negative. Okay, so that there is no relation. Then up to what extent we can claim that there is no relation? Okay, so we have to convert it to the percentage. Okay, so if there is a relation, R value will be positive. If there is no relation, R value will be negative. And that's why R can be negative also. Okay, we cannot always guarantee that there is a relation. So for example, if you go to the market and then find the price of one commodity and find the price of another commodity from the another sector, okay, then the question is, will there be a relation? Okay, so if both the commodities are from the same sector, may possible that there is a relation. Okay, so for example, you consider the home loans and you consider the personal loans. Okay, so both are from the same category, that both are the loans. Okay, so there might be a relation between the rate of interest for both of this. Okay, but if you consider one from insurance and one from loans, okay, so these are the two commodities from the different sectors, then is there a relation? That's the question. Okay, so there may be, may not be, we don't know. When we'll have the data and we analyze the data, then only we will come to know that is there any relation or there is not a relation. Okay, so if I consider the prices of medicine and the prices of grocery, okay, is there any relation? Okay, we don't know. But when we analyze the data, maybe, may not be. So if there is a relation, R will be positive. If there is no relation, and then R will be negative. So that's why the negative value of R is also possible. Okay, so I hope, yeah, that's good. Okay, third point of the remark. Okay, so what we have, the third point of remark, the signs of this all the three quantities byx, bxy, and R will be same. Okay, so for that, what you have to do is you have to see the relations. Okay, what is byx? Byx is R times sigma y sigma upon sigma x, and bxy is R times sigma x upon sigma y. So this sigma x and sigma y are always positive quantities. They are, the definition of standard deviation is that the positive square root of variance. Okay, so variance we'll see in the next module. Okay, in detail we'll see in the next module. Okay, so that's why first I hope some variance you have studied in 12th standard also, some basics. Okay, we'll see in detail in the next module also. But the definition of sigma is the positive square root. So I have given you the formula to calculate, and there I have mentioned that is going to be a positive square root always. So sigma x and sigma y are always positive. Okay, then byx. So if you see byx or bxy, these are the slopes of the line. Okay, so bxy and byx, these are the slopes of the regression lines. So they are called the coefficient of regressions, but they are also the slopes of the regression lines, and that's why slope can be positive, negative. Okay, slope will be positive, slope may be negative, and hence the sign. Okay, so byx is R times positive quantity. Okay, so suppose byx is negative and R times positive quantity. So positive quantity will not affect any sign. That means R has to be negative. And if R is negative, the same thing will happen with bxy. And that's why the byx, bxy, and R will have the same sign. So that was our third remark, I hope. Is that okay, Gaurav? Yeah, good. Welcome. Okay, that's good. Okay, so now let us try the question. Okay, so let us solve the problem. Okay, now we have this, so we have to find out R. Okay, and then we have to find out what is the value of X. So actually here what we are doing is we are making a predictive model. Okay, so because you can see X is going to be 15 here. So X is 15, that means here you will be having 14, here you will be having 15 somewhere. Okay, so actually this 15 is out of range of the given data. Okay, and that's why this type of model, this type of regression model is called predictive model. So what we are building, we are actually building a predictive model. Okay, so our solution will contain a predictive model for this data, and then we are able to calculate what is going to happen this X. Okay, so for example, you have opened a store, and then this shows the sales of the store in after 7 month, 8 month, 9 month, 10 month, 11 month, 12 month, 13 month, and then what will happen after 15 month, or what will be the sales in the 15th month. Okay, so this we are going to predict. Okay, and that's why I said this is going to be a predictive model. So we are building a predictive model for the sales of this store. Suppose I consider X is going to be the month and Y is going to be the sales in whatever the quantity you want to consider. And then we are trying to see what is the trend, or is there any trend, is there any relation, and then how we will grow. So you can see that in 7 months it was 13, in the 8 months 16, 9 month same, 10 month it increased, but in 11 month it decreased. Okay, so what was the effect here? Okay, why it decreased, that can be analyzed. Then again in 12th month it increased, and in again in 13th month it decreased. Okay, so what is the what may be the reason? The reason may be that this stores was closed for more days. Okay, that's why the sales went down. Okay, and like that. Okay, so now we have to find what is the predictive model for this, and then that will be our lines of regression actually. So mathematically, we are finding the lines of regression. Technically, we are finding a predictive model. Okay, so we are trying to analyze this data. Okay, and that's why now let us do this. Okay, so when the when the value that we want to find out is out of range, that means it's a predictive model. Okay, but when this value is in between the range, that is called the data cleaning. So we are finding the missing value. Okay, so we are making this data more clean. Okay, so that's what the techniques we have in data analysis. Okay, so we are building, for this example, we are building a predictive model. Okay, so let us try to find out the solution. Let us try to build the predictive model for this problem. Okay, so what we have here, we can say the line of regression of y on x is. So what is the formula? Y minus y bar is equal to byx. Okay, so this is byx, x minus x bar. This is equation 1. Okay, where what we have, byx is equal to summation xi minus x bar yi minus y bar upon what we know is we know this is xi minus x bar bracket square. Equation 2 is the coefficient of regression of y on x. Okay, and then the remaining terms. So what are the terms we need to know? What is x bar? So we have here, hence x bar is equal to summation xi upon n. What is y bar? We have summation yi upon n. What is n? N is number of observations. Okay, that's what we have. And what is the value of n here? So here n is equal to, see the data, how many data points are given. So it's going to be 7 here. So here we have 7. Okay. Now what we can have is see the question. We have to find out the line of regression of both the lines. So line of regression on y on x we have written. What about the line of regression of x on y? So we can say now the line of regression of x on y is, what is that? You'll be having x minus x bar is equal to bxy. Please use the proper notation. Be careful about bxy and byx. So y minus y bar. Okay, this is equation 3. And what is bxy is, it's going to be summation xi minus x bar yi minus y bar summation yi minus y bar bracket square is going to be 4. Okay, so we have written all the necessary equations. Okay, then from the equations we got the idea what we have to find is, we have to find xi minus x bar, yi minus y bar, yi minus y bar square, and here xi minus x bar square. But before that, what we have to find is x bar and y bar. So for that we have to make the table. So let us consider the table. So what do you have? Consider the following table. And you have seen that this table is same as the table of R. Okay. So we try to have the table here. Yeah. So what are the columns you will be having? X, then Y, then we have xi minus x bar, yi minus y bar, then xi minus x bar into yi minus y bar, then you'll be having xi minus x bar square, and we have yi minus y bar square. Okay, so these are the columns we have, and this is the table we'll have. Okay, so we are not interested in these two figures. So where we are interested? We are interested here. Okay, so these are the columns of our interest. Okay, so what we have to do is we have to find out what these figures are. So we can write from above table we have. So what will be having? X bar is equal to summation xi upon n. Okay, and we have y bar is equal to summation yi upon n. So here in this case is going to be by 7. N is 7. Now I want you to write down these values. So what are these values are? We can say 7, 8, 9, 10, 11, 12, 13. Okay. So this is going to be 7, 8, 9, 10, and the last having 13 here. So I want you to calculate these values and give me the values. What do you give? So what is summation x and summation y that I want you to give me. So make the table. I hope you're calculating with me. Okay, so make the table and then give me the value of what is the value of summation x and what is the value of summation y. So we can calculate your good summation x and y, and then we are able to calculate x bar and y bar. Okay, so anybody else got this? Some Anushka has got this sum. What about others? Oh, Gaurav has also got the same. Okay. Advait has calculated a mean. Okay. Oh, okay. So whatever you will get, you just make a comment. Okay. Then I'll come to know that what you got. Okay. So you got the sum. That's good. Let us find the means. Okay. So what do we have here? You got the sum here and here. Okay. So you got the sum to be 70 and this is 113. Okay. And now once you got the sum to be 70, so we have here, this will be 70 and this is 113. So here you got the mean is going to be 10 and here you got 16.14. Okay. That's great. So you got both the means, and once you got both the means, now you can calculate these two columns. Okay. So xi minus x bar, yi minus y, and then you are able to have the multiplication of these two and the square of this two columns, and then we are interested in this value, and this value, so that we can calculate the remaining. So I want you to calculate the table with me. I am also calculating. Okay, so let's calculate. Now, once you are ready, then you tell me. So we'll see whether your answer and my answer matches or not. So once you got the mean correct, then definitely your remaining calculations will be correct. Please calculate and then have the sum of x into y, x square and y square. So I hope you got the values. Okay. How many of you got the values? Summation of x and y is x. X and y is 19, or x into y is 19. Akhilesh, x into y. Correct. Okay. So Mukul got the values. Summation of y square also you got. That's a good one. Okay. Okay, that's great. So you are getting good. So how many of you have got it? Most of you got the same. Okay. So let us match your calculations with my calculation. Okay, that's great. Okay, most of you got it. Good. Okay. So see, these are the calculations that you should get. How many of you got this calculation? So summation xi minus x bar yi minus y bar is going to be 19. Summation xi minus x bar square is going to be 28. And summation yi minus y bar is going to square is going to be 26.857. Okay, so some of you might have got the some with the more accuracy. So you have got it. Okay, that's great. Okay, so 572. Okay, that's good. Okay, so now once your calculations are done, okay, so what we got is we got this all table ready, and hence now what I can write is I can write from equation 2. Okay, so first we have to calculate the coefficient. So we have what we are having here byx is equal to. So what is the byx? Byx is summation xi minus x bar into yi minus y bar upon summation xi minus x bar square, and this is 19 by 28. So what is the value you got here? Okay, so what is the value you got here? What is the value of b by x you got? 0.6785. That's great. Okay, so you got a value to be 0.6785. Okay, and hence we got here byx is equal to 0.6785. Okay. Now, once you know the coefficient, we are able to calculate the line of regression. So what we can say is from equation 1, we have what we'll be having by minus 16.1428 is equal to, this is byx, so 0.6785, and x minus x bar. So that's going to be n. Okay. So we have this, and now let us simplify this. So y minus 16.1428 is equal to, this is going to be 0.6785 into x minus what do you have here, 0.6785 into n. So you can have this value on the other hand side, and hence we get y is equal to 0.6785x minus this will be 6.785. Okay, 785, and you'll be having plus 16.1428. Okay, so that's what you have. Now calculate this and give me the value of this coefficient. So we can write here the line of regression of y on x is given as. So you got y 0.6785x, and what this value is plus. So this coefficient will be plus. So give me this value of this coefficient. What you get is 93575, 3578. Okay. So I consider that 357 is good enough. Okay. So here we get 9.357. Okay. So this is the line of regression of y on x. Now we want to find what is the value. Okay. So at this is our predictive model now. So at x is equal to 15. Okay. We have what will be y. This will be 0.6567 6785 into 15 plus 9.357. So give me what is the value of y you get here. People have some more digits. Yeah, that's good. 5353, 5345. Okay. So this three values are with the different. One is 5353, other is 53545. The next is what is the correct answer? See, all the calculations, all of you must get the same answer. Okay, because all of you are considering the same accuracy. So 5353 is close. That's good. Okay. So what you have here? You'll be having this is 19.5353. Okay. So that's what answer we accept. Okay. So here we got this value. Okay. So we got the value of y at x is equal to 15. Now next what we have is we have another line of regression. So from equation 4, because we have to find out the regression coefficient first. Okay. So we have, okay, what we'll be having pxy now. So it is summation xi minus x bar. This is into yi minus y bar. Upon you have summation we'll be having yi minus y bar square. Okay, and this is going to be 19. This is going to be 26 point. So what is value we have obtained from the table? So you can see 26.857. Okay, so that's what this is, 8572. That's the value you have obtained. Okay, and hence what is the value? What is the value of byx? So bxy now. So what is the value you got for 0.7074? What about others? Okay, that's good. Okay, so you got here 0.7074. So we accept this 0.7074. Okay. So you got the value of bxy. And now, if I know the value of bxy, I know the value of, I know how to calculate the line of regression. So what you'll be having from equation 3. Okay, we have, okay, so what we'll be having, x minus 10 is equal to 0.7074 y minus y bar. So it is 16.1428. Okay, and that's why what you got is x minus 10 is equal to 0.7074 times y minus 0.7074 times 16.1428. So you have x is equal to, so it is 0.7074 times y, okay, minus this is 0.7074 times 16.1428 plus 10. Okay, so that's what we have, and now we can say the line of regression of x on y is. So you got here x is equal to 0.7074 y, and then give me this coefficient. What this coefficient is going to be. So what is the value of the coefficient of the constant you got? Have some more digit. Uh, minus 1.4194. Okay. How about others? Okay. 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 So you got minus 1.4194. Okay. So 9394 is good to close. Okay. So that's great. So you got minus 1.9194. What do you have here? So it is going to be 4194. So this is 4194. Okay, so this is the value of the this is the line of regression of x on y. Now we have to consider the r. We have to calculate what is the r. So if there is any relation in this data, what is or what confidence we can have for this relation? R we have to find out. Okay, so we know in the remark one, I have given the value of r. So what we can have is we have r is square root of dxy into dyx. So it is going to be square root of 0.7074 into 0.6785. And moreover, you can see both these coefficients are positive. So the value of r will be positive. So what is the value of r you are getting? You just tell me. Positive square root of the product of two regression coefficients. So it's going to be Akhilesh got a value. What about others? Yeah. So 6927. Okay, that's great. So you got this is going to be 0.6927. So you got R is equal to 0.6927. Okay. So we can say 69% that there is a relation. Okay. So our confidence level is 69% that there is a relation between these two data sets given to you. Okay. So that's a good one that we can claim that there is the relation between these two attributes. So is there any doubt in this session or whatever we have solved up to it? Is there any doubt? No doubt. Okay, that's good. Great. Okay, so let us try the another example. Now, see, these are the examples where you need to calculate efficient way. So if you can use your calculator efficiently, you will able to solve this problem in less time. So let us try one more example. So now we are given the processed data. Okay, so that's what we have here. The data is already processed. We have given the line of regressions, and we have given the sigma x square. Then what we have to find out is we have to find out x bar, y bar. We have to find out r. We have to find out this variance. This sigma x square means it is going to be the variance of x, and is the variance of y. So we have to find out the variance of y, the coefficient of correlation. Then we have to find out the x bar and y bar. Okay, so we have given the two lines of regression. Okay, and hence what we start is let the line of regression of y on x is. So here, out of these two lines, we are considering the randomly that this is going to be on of y on x, and this is going to be of x on y. Okay, so as it is y is expressed in terms of x, so we are considering it is to be of y, and x is in terms of y, so we are considering this line is to be of x. So y on x is what you have, 5y is equal to 4x plus 80. So I can write this as, okay, this is the given one. Okay, I can write this as y is equal to 4 by 5x plus 80. Okay, and if you remember, what is the line of regression? We have got y minus y bar is equal to byx and x minus x bar. So that means if I simplify this, y is equal to byx into, okay, so here we have x and plus, what is the term we will be having? Y bar minus x bar into, here we will be having y bar minus, so this is y bar minus b by x into x bar. Okay, so you can see the coefficient of x is b by x, and hence I can write here we have b by x is equal to 4 by 5. So you can compare with this. Okay, so I can make it 2. And now what do we have the next? Now we have the line of regression.
Sir, 80 should
Of,
be also divided by 5.
yeah. Okay. So of x on y is, okay. So you got here this line of regression. So what is given? Here we have, this is 40 is equal to 3 by plus 10. Okay, this equation 3. And now I can write this as x is equal to, so it is 3 by 14 by plus 10 by 14. Okay, and now similarly I can have the line of regression of x on y. So what we know is x minus x bar is equal to bxy, y minus y bar. And so what we got here, x is equal to bxy into y plus x bar minus bxy into y bar. Okay. So we can compare the coefficient of y is going to be bxy. Okay, and hence what we get here, we can get that. So I get here bxy is equal to 3 by 40. And now we have to check whether we are whatever the calculations we have done are wrong or correct. Okay, so these calculations are correct. Why? Because you can see the sign of bxy and byx is same. Okay, so you can see this is positive, this is positive. If it happens that one is negative, another is positive, that means your calculations are wrong. Okay, so if both are negative, that is fine. If both are positive, that is fine. But it cannot happen that one will be positive, the other will be negative. Okay, so here we got this two values to be positive, and hence these calculations, whatever we have done, are correct. Okay, and using this, we are able to find the value of R. So we know the remark. Okay, and hence we have what we'll be having here. So R is equal to square root of Vxy into V by X. So it is square root of V by 14 into what we have here. This is 4 by 5. So here we got this is 4 by 5. Okay. So what is the base possibility? You can cancel only 2. Okay. So it is going to be V by 7 into V by 5. So give me the value what you will get. Definitely it will be less than 1. So what is the value of yeah, you got 4140, 414. That's okay. That's good. Okay. Great. Okay. So you got a value 4140. Okay. So this is going to be 0.414. Okay. So what we got here, we got the value of R is equal to 0.414. Okay. So now we got this. Okay. And next, what do we want? We want to calculate X bar and Y bar. So the means X bar and Y bar satisfy the lines of regressions. So what we can say is from equation 1 and 3 we have. Okay. So what we'll get from the equation see this equation I can take this 4x on the other hand side and I can write this as okay. So I can write this as minus 4x plus 5y is equal to 80. Then from equation 3, what I am able to write this as 14x minus 3y. Okay, so it is going to be 14x minus 3y is equal to 10. Okay, and then as we know, this x bar and y bar satisfy these two equations. That means x bar and y bar are the solutions of these two equations. So if I am able to solve these two equations, then their solution will be x bar and y bar, and hence uh, that is okay. So you can say the uh, solution of both simultaneous linear equations is the values of x bar and y bar. Hence, solving both equations we get. So you have calculators, you can solve these equations by using calculator. This is just a 2 by 2 system of linear equations. And then tell me what you get. Okay. So x bar is equal to and y bar is equal to. So what is the value of x bar and y bar? That's good. So you got x bar is equal to 5 and y bar is equal to 20. That's great. Okay. So you got x bar is equal to 5 and y bar is equal to 20. Okay. So once you get x bar and y bar, okay. So now what remains to find is sigma y square. Okay, so we have calculated this, we have calculated this. Now we have to calculate this, and the given information is x square sigma x square is equal to 16. Okay, so what we know is then we have sigma x square is equal to 16. So we have sigma is equal to we can write root of 16, and always positive root. So sigma x is equal to 4. So we got sigma x is equal to 4. Okay. Also, we have you can choose any of the regression coefficient bxy or byx. So I choose bxy is equal to r times sigma y sigma x. Okay, so this is the formula that we know, and hence what I can write is I want to find out sigma y. It's actually sigma y square. So sigma y will find out first. So I can have this is sigma x into byx upon r. So sigma x is 4. Is going to be 0.414, and byx. So we can see byx is 4 by 5. And so can I have this one. Okay, byx we have calculated, and that's going to be 4 by 5. Okay, r we have calculated, and then sigma x we know. So we can put all this value. So what we can have is so give me the value of sigma y, what you are able to get. Okay, so what is the value that you are able to get? You got 7.294. 7.7294. Okay, that's great. Okay, okay, that's good. Okay, so you got this is going to be 7.7924. Okay, I hope that's correct. 7.7294. Okay, 7.7294. So you got 7.7294 is the value of sigma x. But we are interested in sigma square. So we get sigma y square. Okay, so it is going to be what is the value you have calculated? So it is going to be 59.7447. Okay, so it is 59.7447. Okay, and that's what you got. Correct? Yeah, 4647. That's okay, good enough. So we got this one. So this was our target to get this. Okay. So please be careful while writing the notation. So this is sigma y square and sigma y square. Okay. So it is sigma square. So this is going to be variance. Okay. And this is going to be the standard deviation of y square. So that's why please be careful while writing the squares and the notation. So anyone of you have any doubt this question? So do you have any doubt in this question? Okay, so great. Okay, so I hope you understood this whole concept, how we are able to find out the different parameters when we know the process data. Okay, so the directly line of regression is given to you. That means the data is already processed. So in the first part, what we did is we processed data to find the model. Now model is given to you. You have to find the parameters. Okay, so these are the two ways. One thing, Model will be given to you. You have to find it or find the parameters, or the data is given to you. You have to find out the parameters as well as the model. Okay. So in the first case, we calculated the model. In the second case, we calculated the parameters. Okay.